everybody, and welcome to the i3Net interview series. Today, we have a really interesting presentation for you. This presentation is talking about how and why the things that we're making are changing and can change through 3D printing. And this exciting technology is something that's happening right across Australia. And we've got some really exciting innovations coming to the Illawarra as well. So what I will do is I'll hand over to Josh from Assett Professional Services. Josh and Assett obviously are part of i3Net, wonderful active members of the network. So Josh, I'll hand over to you if you'd like to introduce yourself and kick things off.
Thanks, Bianca. I just wanted to start today with introducing Assett and our partnership with Konica Minolta and tell you a little bit about Assett and what we do. So Assett's a technology company here in Wollongong, and we specialise in the ongoing management of copier and printer fleets, so from office to industrial, IT and communication infrastructure, and cybersecurity solutions. So our clients are small to medium businesses and government bodies. And one of the things Assett does is keep up to date with the latest technologies, and we form partnerships with the world's best technology manufacturers like Konica Minolta and developers to enable our clients to realise their full potential. So what I wanted to do next was to hand over to Matthew Hunter from Konica Minolta to take you through an introduction to Konica and also to the 3D printing technology.
Yeah, thanks a lot, Josh. As Josh mentioned, my name is Matt Hunter. I am the Innovation Product Manager at Konica Minolta Australia. Thanks very much for having me. It's great to be talking to i3Net and I guess getting the opportunity to talk to organisations a little bit more about 3D printing and how it's impacting manufacturing. But first off, a little bit about Konica Minolta. Obviously, we're a 140-year-old company. We've got 2 million customers worldwide with almost 44,000 employees in 150 different countries around the world. But really, what we wanted to talk to you today is from the experience of being a manufacturer like many of you. So some of you out there be working for companies that might even be bigger than Konica Minolta, in Australia that is anyway, and some smaller, but I'd say that we're aligned in many of the struggles that we're facing day to day, and particularly during a time in our lives where we're being impacted by something that's unprecedented like COVID. So for many of us, COVID ultimately will change the way that we live and work, and very few of us have a natural immunity to COVID, and I guess the same can be said for our businesses. It can make us and break us, and one of the significant impacts that we're facing is positively an upsurge in demand for Australian-made products, which is awesome. But there's also a headwind that sits in front of that, and it's keeping our supply chains open so we can fulfil demand. So I guess what we've been talking a lot about is a time to rethink global supply chains, or at least tweak them a little bit in our favour. Over 100 years, we've honed mass manufacturing processes, mainly to make them efficient and cost effective. But along with that efficiency tends to come centralisation of production. And this comes at the mercy of a global supply chain, which we're all experiencing at the moment during an event where, across the world, this is manifesting itself into a large concern, particularly, given the circumstances here in Australia, we are isolated from our supply chains by a very large expanse of ocean. These supply chain issues can take on various forms, and in particular, we've been working a lot with the food and beverage industry on keeping their plants open and operational, and it can be lots of different reasons. So it could be obsolescence, just the equipment that you're using to manufacture the supply doesn't exist anymore. It could be a particular part required to keep machinery operational. It could be that the cost of a part has increased tenfold. It could be that you need to customize existing infrastructure to make you more competitive or bring new products to market. The way we have traditionally manufactured, combined with the current global conditions, is kind of working against us. So where does this lead us? The way things are made is changing. We're moving from a more traditional analog way of manufacturing to a digital way of manufacturing, where we can truly manufacture on demand in anywhere, anytime, in any shape. So imagine taking your design and optimizing it for 3D printing, have your prototype, your product or your tool, available to you, or in a very short amount of time, leading to better control, reducing your lead times, reducing your downtime, reducing cost, and making you more productive. Imagine not being a slave to minimum order quantities. You just print what you need. 3D printing is helping companies realize this outcome here in Australia now and in your region. So what is this concept of digital distributed manufacturing? Well, it's an approach where over time you convert parts into a digital file that can then be reproduced on demand. So digital inventory can be created in a number of ways. It might happen naturally over a period of time using processes like 3D scanning or reverse engineering based on original 2D part drawings. You might have the CAD file, or you might take open source files that have already been developed and edit them to suit your application. These part files then exist as ready to print parts located in an organizational cloud infrastructure that can be downloaded and manufactured in the location required. And so the diagram that I've created in front of you is a setup that's actually being utilised or proof of concept by the red meat processing industry here in Australia now, where they are putting, I guess, smaller end-use printers in each location, and then backing that up with a centralised metal printing facility here in Australia to keep their plants and processing plants operational. So it's a constantly evolving ecosystem, and I guess investing in digital inventory is not just purely about replacing a physical part. Many of your organisations have got smart people on the ground with ideas on how to improve your processes or parts to overcome problems on site, which can improve parts. And we use these kind of things that we loosely call design thinking principles, but that just because the way a part is made traditionally doesn't mean that it's the perfect part. It's probably be designed like that purely because of a limitation around how you actually manufacture the part. And a lot of times you could lightweight it, you could add additional materials to strengthen it. You could combine multiple parts into one, which means you've got less failure points, less inventory. So digital inventory isn't just purely about replacing like for like, although it can be that. Digital inventory is a constantly evolving ecosystem that gets better over time. So that not only overcomes a supply chain issue and keeps you productive, but it also gives you a better part, which improves uptime. Certainly we know this is important, in particular in the food and beverage manufacturing industry, but a lot of other industries where you're producing products with a really short shelf life. Your teams on the ground will have ideas on how to add features and customize parts to get better results. We know that once organizations adopt this equipment, that there's an added benefit that is realized as your teams gain experience with it. And I guess Konica Minolta and Assett are here to help you fast track that with the right consultancy and equipment and training. So how does digital manufacturing add value? Purely it can be, as I discussed earlier, the cost of a part or the performance of a part, so making a part perform better, reducing downtime, overcoming obsolescence. It can be printing things on demand, optimizing your inventory, reducing cost and last mile logistics, so improving your logistics, which all has an impact on productivity. wide range of proprietary materials. So, one of the things that's helping 3D printing being adopted is the growth in materials. So it's no longer purely about prototyping and testing parts before you go to a traditional manufacturing process. It's a legitimate manufacturing process in its own right, and the growth of materials has really driven the adoption of 3D printing into organisations, as it's become a real tool on the workshop floor that you can utilise alongside a lathe or a welder or a CNC mill. And that's, as I mentioned, the growth in materials. And you can see just a really small snapshot of some of the materials that you can manufacture using 3D printing or additive manufacturing. And we're probably going to cover a little bit more off on those in some of the question and answer component of this at the end. Thought I'd cover a little bit about some of the verticals that are really adopting the technology, and in particular, there's a couple here that stick out for me in your region. Aerospace, for instance, if any of you know a company called Air Affairs, they are certainly headed down the path of 3D printing. Obviously, they have a large traditional manufacturing facility in your region, and a lot of CNC milling, but more of late and recently they've adopted some 3D printing technology, which is used for 3D printing carbon fibers. Looking at replacing traditionally manufactured parts in aluminium with carbon fiber, lightweighting parts, printing parts that couldn't be traditionally manufactured. And that's the strength of using something like 3D printing. Obviously the military, and you see the US Army and Navy, one particular, the Australian Navy and Air Force have now gone down this path. There's actually a 3D metal printer on one of the bases down in your region that was purchased just recently, along with some carbon fiber printing, which they're using in some aerospace applications actually. Automotive is a really interesting one as well. And we've got a number of aftermarket automotive manufacturers that are using 3D printing for a number of different reasons. And we typically don't think of, I guess, automotive in Australia because a lot of the large mainstream manufacturers have moved offshore, but there is a significant aftermarket automotive industry here in Australia, and we have guys that are converting left-hand drive to right-hand drive, restoring vintage motorcycles, a bunch of those types of applications. In particular, actually in Newcastle, there's a lot of them based out of the Newcastle region. So there's a lot of different applications, robotics, end effectors, jigs and fixtures, replacement parts that apply to these industries and many others. So this is just a snapshot of, I guess, some key verticals that are really taken the technology and run with it. So how to mark forge? Well, mark forge are one of our suppliers, and we can talk about that a little bit more. But also, when I say how do we partner with you, I include Assett in that. They're our partner in your region. So how that typically would work is it comes out of consultancy. So it's great to have the technology, but you need the support of an organisation to assist in a couple of different ways. One is to discover and uncover opportunities to use the technology, and the other is the support that you wrap around it. It's great to have a piece of infrastructure like this, but once it becomes a critical piece of your infrastructure, if you don't have somebody in your region that's going to support it, service it, come out on site if it's down for any reason, supply consumables and support around it in a timely manner, then you can't really use it as a critical piece of infrastructure. And that's where Konica Minolta and Assett fit in with you to help you adopt this type of technology. And we'll talk a little bit more in the question and answer section about, I guess, how you identify whether or not 3D printing could be right for your organisation. With that, I guess I wanted to flick to the next slide, and that is a little bit about if you want to learn more. And I don't know, Josh, if you wanted to cover off how, I guess, organisations within i3net engage with Assett and us as an extension of Assett.
Yeah, thanks, Matthew. So they could either contact me directly with the details there on the screen, or contact me through Bianca and i3net group, or even at the events if they wanted to just, come and have a chat to me and learn a little bit more about it, then they're always welcome to do that also.
Yeah, great.
That's awesome. Thank you, Josh, and thank you, Matt. I think that was a really good speedy snapshot of what's available. Matt, I have a couple of questions that I've written down as you were going through, and it was about, and you did mention in your presentation, just talking about for me with 3D printing, a lot of the conversations have been about producing prototype parts. And there has been a lot of conversation over time about the materials and that improving, and it was great to hear some of the examples, but I would love for you to be able to just share some more information about that, what people can actually produce, just to go into that in a little bit more detail, just to align with the industries in our local area.
Yeah, sure. I mean, it's interesting that the materials that you can print are probably the fastest changing part of 3D printing. There's probably a dozen different, I guess, methods of 3D printing, or well-known methods of 3D printing, and actually the fastest changing part of that is that it seems like every other month there's a new material that is available to 3D print. And I guess, as you can imagine, it's the actual, if you're thinking about how you're going to apply 3D printing, I quite often take it back to what the part needs to be able to do. And it might be that you need some part that's incredibly strong, or you might need it to be made out of titanium or aluminium, or you might need carbon fiber, or you might need a biocompatible material for a medical application. You might need a fire retardant material for an aerospace application. You might need an electronic static or electrostatic dissipative material for the electronics manufacturing industry. Those materials are the fastest growing part of the industry, and what that does is it just means that there's more applications that you can use 3D printing for, so there's more opportunity to adopt it within your organization. And and businesses are doing that, and they're doing that really effectively. So materials growth is what I guess opens up 3D printing to organizations, because it allows them to apply it to a specific application within their organization. Now that's really grown, I guess, the end use part of 3D printing. So if you were to kind of think about all the parts that come off the end of 3D printers in a kind of pie chart, prototyping would only be 30% of that. Almost 40 to 50% of the parts that come off 3D printers now are considered end-use parts. And then there's another chunk of them that we would term augmented manufacturing. And augmented manufacturing is where you might be using 3D printing to overcome part of the manufacturing process, but it might not actually be the end-use part that you're manufacturing. And a way of kind of describing that would be, in particular in the jewelry manufacturing industry, for instance, predominantly, by and large, most of the jewelry that's produced now is done using 3D printers to print a lost wax pattern, and then they go back into the traditional casting process. So that's utilizing 3D printing to make themselves way more efficient at what they do, by taking a part of the process and using a 3D printer to overcome that.
Yeah, that's awesome. Thanks, Matt. It's a really great answer. One of the other things that I thought was really interesting was talking about that whole team learning experience, and the fact that, yes, you might have this great piece, of technology in your business, but how the more people use it, the more that your team actually learns and uses that more, and that actually builds on the value. I found that really interesting. Did you want to expand on any on that further, or some examples on how that happens?
Yeah, so I mean, as you can imagine, like typically when we engage with organisations, there's one issue that they're trying to overcome, and 3D printing, is an avenue or a vehicle to overcome an application issue. But more often than not, we find once organisations have that technology in their hand, they find other applications within their organisation to apply it, and that's typically that you find this one sweet spot that is going to help you overcome a problem, and it demonstrates an ROI and value to your business. Otherwise, you'd never make that decision in the first place. But then you put that in the hands of your team members and staff who have millions of other ideas on how they could apply 3D printing. As they learn more and more about it, they go, oh, that's right, I could use a 3D printer to overcome that other issue that I'm facing in the organisation. So as organizations get more and more experience with the technology and they apply it more and more, they find more and more uses. And we find what happens is people start down the path of 3D printing, and then within 6 to 12 months, they're knocking on our door again going, that other technology that we spoke about that prints in this material or that material, we need to now have a look at that, because we've decided we have applications for that within our business also. So people don't tend to stick with one 3D printer. They adopt one, they get experience, and then they grow from there.
Yeah, awesome. Actually, that was going to be my next question in a way. It was talking about that whole cost and the ROI and making the decision. And so how does that work for businesses? So I guess if you can talk about that usual consideration process for people thinking about it, to doing it, what the costs are, but then also if they, work out in 6 months' time that, they need a completely different model. Could you chat about how that works?
Yeah, so the whole process that we go through with organizations when we're going down the path of exploring whether or not 3D printing is right, and is an interesting one. So it really starts with, I guess, organizations having a problem to start with, and the one that sticks out recently for us is obviously people have massive supply chain issues at the moment. So that's one thing that's driving it, but it's walking the floor, and it's doing what we call walk the line. So you're walking the floor of your organization, you see a problem that you think maybe 3D printing can overcome that, right? And then what we would do is we would come in and talk to you about that, help you figure out whether or not that's a good fit for 3D printing or not. And there's a bunch of considerations there. One could be the size of your part, the number of them that you need. It could be the material that you want to print in. It could be that we come in and go, look, that part as it stands is not a very good part for additive manufacturing because it's been designed to traditionally manufacture. But if we assisted you in changing the design of that part, it would be appropriate for 3D printing. So we dig deep into those applications and understand, one, whether there's a good fit for 3D printing or not, and whether there's a 3D printer that could help you overcome that. But then we take that part and we go, okay, well, what's it cost to traditionally manufacture that part, and what's it going to cost us to 3D print it? And then the sort of volume. So it becomes this kind of, we move on from, is the application going to work, to is the financials going to stack up around the application? And then once we kind of get to that point, typically what we would do is actually manufacture the part using a 3D printer on behalf of the organization. And then we move into, I guess, a more physical. You've got the part, you might put it into a piece of machinery and test it. An example, this could be an organization we've been working with recently. They part of their packaging line requires what's called a pick head. So it's an end effector on a robot, and it's moving packets of things from one conveyor onto another. And that was costing them an exorbitant amount of money to import these from Denmark. And they fail, because they're moving 2 times a second, they fail after a period of time. Now, we work with them on not only just remanufacturing that part at a much cheaper cost, so taking a cost from like $16,000 down to $400, but also we work with them on redesigning that part so that they actually get more use out of the part, so it doesn't fail as much. So we dig into these parts, then we end up manufacturing a part. It might go into the piece of machinery, proves out the concept, and then typically, organisations make a go or no go decision on whether or not they want to go down the path of adopting the technology.
Yeah, that's awesome. Thank you, Matt. That was actually the end of my questions. Did either of you want to think of anything along the way that we should share before we wrap up?
I guess the only additional thing I would expand on is, and it's probably the question that a lot of people have in their back of the mind, is, what does 3D printing cost? And I guess the cost of 3D printing is a hard one to nail down. Obviously, working with you on, a return on investment on a particular application is probably a better way of going. But I guess the hardware kind of ranges, if you're talking about a proper industrial machine from about 15K to north of 1.5 million. And, I guess the types of reasons why they are more expensive than each other typically are either the size of the build platform, so the actual volume you can print, and there's a couple of reasons why the volume you can print is important. One, you might have really big parts. Two, you might want to print a lot of small parts at the same time to create a volume manufacturing kind of infrastructure. The other thing that typically changes the capital equipment value is the type of materials that you can print. And obviously printing in plastics is a lot more cost effective than printing in metals. And that's why, a lot of people are really interested in, composite manufacturing or 3D printing with things like carbon fiber and fiberglass and Kevlar and these sorts of materials, because you can actually potentially replace metal parts with plastic parts. So there's a kind of common misconception out there around 3D printing, and that's kind of driven out of, I guess, the rise of a consumer model 3D printing, which a lot of people kind of have had some exposure to. Is quite limited. It's great from the perspective of it's really driven awareness of the technology, but it hits its limitations pretty quickly. So I just wanted to expand on that.
Yeah, no, that's awesome. That's really great. Thank you, Matt, for doing that. Look, I think that was a really great snapshot of information. Matt, thank you so much for you being able to articulate that. I mean, there's so much in these printers and there's so much that you can do. I think that was a really concise snapshot of what's available in that technology. And what I was really happy to hear about was that support along the process, because obviously this is a significant investment if people are looking into this space, and to actually find out about that support and how you actually work with people to ensure they get that value and that ROI is really encouraging to hear. So thank you for sharing that. And Josh, thank you so much as well. I think, this was your idea to have this great conversation to bring this information forward to the network. So thank you, Josh, for that. We love working with Assett, and really happy to have you as part of the network. And hopefully at our next in-person event, we might also potentially be bringing some 3D printers along to that. Thanks to Josh and to Matt.
Yep.
Yeah, absolutely. Thanks for the opportunity. And as I say, it's great to have such a good partner and Assett, working alongside us.
Fantastic. Excellent. Well, thank you, Matt, and thank you, Josh, again. And thank you for everybody for watching. If you would like to find out more about this great opportunity, Josh's details are on screen. You can also reach out to me. And yeah, we look forward to bringing this exciting technology further into the region. So thank you.